Bonjour à toutes, bonjour à tous. On est ravis de vous accueillir chez Botify pour vous parler un petit peu de Botify. Donc, c'est une entreprise française qui a été créée en 2012. Et en fait, on aide les sites Internet à être mieux visibles sur les moteurs de recherche. On est aujourd'hui 300 salariés répartis dans le monde. On a des bureaux à Paris, New York, Londres, Singapour. Et on espère ouvrir d'autres bureaux. Et on est très content de vous accueillir. N'hésitez pas à rester après les talks, parce qu'on va aussi vous proposer à boire et à manger. Et comme ça, on pourra aussi discuter tous ensemble. Et n'hésitez pas à suivre notre actualité sur notre page LinkedIn. Et on a notamment toutes les actus techniques et aussi toutes les actualités concernant nos postes ouverts. Voilà. Merci beaucoup. Bonne soirée.
Okay, so good evening, everyone. For those of you who subscribed when the event was still written in French, I'm sorry. There was a slight change because, as you know, it's a hors-série meetup. Basically, we had a discussion with the organizing team when we read that France was going to use video surveillance during the next Olympic Games. So we're going to talk about heavily technical stuff, as usual. And it might be full English. If there is one talk in French, it will be because you will have decided. Okay, so for those of you who came for the first time, we are the Paris machine learning team. Yes. Who's here for the first time? Wow. Okay, so the explanation is going to be useful. WiMLDS stands for Women in Machine Learning and Data Science, and it's a global nonprofit which was created in the US, and we support women and gender minorities in the field of AI, so machine learning, data science, and we aim at being super open, whether you're studying it, whether you're doing a different job, or if you're doing research, everyone is welcomed. We do have a code of conduct. The ones who are like used to come know it by heart. We like technical questions. We like when people are extremely respectful, and we are always very nice, especially when you are as well. If we notice an inappropriate behavior or comment, one of the organizers might come to you and have a discussion, and then we'll decide what happens. But I do invite you to be respectful, and everything will be fine. Are you scared right now or not? Globally, we have more than 60,000 members. There's more than 100 chapters all around the world in every continent, which is extremely interesting. And Paris is the third largest chapter. And now I'm going to invite all the organizing team. Chloe is not here because she is not in a good condition, but I would like to introduce Nathalie, Juliette, Jihan, Marie, and myself, Caroline. So we are the ladies working for it to happen, and we're super happy to see you tonight. If you want to volunteer, if you have questions about what we do not hesitate to come and ask questions to us at the end of the talk. Okay, thank you. It was staged, obviously. And you'll see every meetup will start with recommendations. So the first one is about a reading paper club. It's very similar to what we do with the brown lunch bag sessions we organize. So have a look at it. It's called the Gathers.ai Papers Club. It's free to attend. So have a look. It was recommended by Jian, and it seems like they are very serious. Second thing is a Women in Data /AI festival. So it's happening in Berlin. If you travel or know people over there, the lineup is exclusively women speakers, and we do have promotional tickets. So if you're interested, we could share what we have with you. And in the same kind. It's in Paris this time, the AI Night organized by Datacraft. It was a previous host from WiMLDS. On the 26th of June, they are going to hand awards to companies, to groups in different categories, and they are extra cautious about diversity and inclusion. So if you're interested to network or to have a look at the landscape of the companies they are going to reward, again, feel free to reach out to us. We put the email address paris@wimlds.org. And now, let's deep dive into why this meetup. So in March, when everyone was protesting against the new law for the retirement in France, something happened overnight. The French Parliament voted positively for France to be able to use facial recognition tools during the Olympic Games. So it's supposed to be a phase of test, but we are scared that it's not going to be just a test, and these techniques might be used in the future as well. And there is a broader issue to this, because nonprofits have alerted the press, everyone they could, including French representatives, about the risk of reducing our freedom, especially in the public area, and we failed. And I also wanted to stress one point, is that in other countries, especially in the US and in California, they prevented these tools to be used. Is there a link with how techno-savvy people are there? It's an open question. The thing is, there was data which was shared last year from Ipsos, and you could see, depending on the areas, products and services using artificial intelligence have more benefits than drawbacks. The data, for those who can't see, China is the first country, and people are answering by 78%, Saudi Arabia 76%, then India. I don't need to go on with the list, but these countries are either what we call démocrature or authoritarian regimes. And France is at the bottom. Only 31% of the French people answered it was bringing benefits. So there are awareness to bring, and we wanted to address the question in order for you, for us to have the conversation and to talk about it publicly. Because right now it's really unnoticeable. Only very concerned people are aware of it. If you want to go further on the topic, La Quadrature du Net shared several articles on the matter prior to the vote and after the vote happened. Without any transition, if you want to connect with us, here are where we are. Instagram, LinkedIn, Slack, if you want to join and have a conversation with us. We do have a YouTube channel, so hopefully tonight's meetup is going to be on our channel if Botify agrees to share the video. And without further ado, I'm going to introduce tonight's agenda. We're going to kick off the session with Julie Delon. She's going to talk about plug and play. This talk will be your choice, either in French or English, right? Okay. Then we're going to listen to Ruth Binkyte. Ah, ouais, je l'ai fait. And Francesca Iannuzzi. And if you want, we can have an open conversation at the end, depending on the time left we have, about the surveillance tools or about the presentations. But be aware that after every presentation, we'll have a Q&A session with this mic. And Guillaume kindly told me to invite you to do like me, put it on your chin, and the sound should be good. Okay? So now we're ready, and Julie can come on stage.
Hello, everyone. So let's see if it works. Okay, it works. But I'm too old right now, so I have to put this just to read, but not to see you. So it's horrible. Okay, so I can use this and this, it works. Okay, perfect. All right, too much tools in my head. So hello, my name is Julie Delon, and I work in a university, Université Paris Cité, and I am an applied mathematician. I know nothing about video surveillance, so this talk won't be about video surveillance, but well, I will take most of my example in image processing and imaging science because it's my research domain. Oh, I didn't ask. Do you want to talk in English or French? Who vote for English? Okay, so if you want it, okay, you win. Sorry, I didn't ask before. So yes, so I will speak about what we call plug and play methods. Those are methods, optimization methods, in a way, and they are more general than image processing, but I will tackle my example in image processing because that's what I know. So okay, so first a small context, bit of context. So as I said, I work in imaging science. For most people, images are what you take with your smartphone. So there are more smartphones than people in the world. So a lot, too many images on Instagram each day. And you know this. And no, I don't know. Do you use Instagram? Yes. But of course, imaging science is not only photography and not only the movie industry and Netflix. It's also a lot of important stuff. I don't say that photography is not important, but it's also other important stuff like medical imaging or satellite imaging, with a lot of application in basically all areas of society or for life. Okay, so what is an image? For me as an applied mathematician, it's a grid of pixels, and you know all of this, but yes? Okay, so I can put the next slide. Yes, no, something important. For me, images are vectors, okay? So I read an image column-wise, and it's a vector, a huge vector of size several millions. Okay, if it's too easy, you can tell me it's too easy, and okay, so I will speak about inverse problems. So why do we have problems that we call inverse problem in imaging? It's because when you acquire an image, whatever the application, basically you never have what you want to acquire. There is an ideal image, and what you acquire, you have degradation, you have blur, you have a lot of, you can have noise, for instance, in astronomy. Sometimes what you acquire is not even an image. For instance, if you do an MRI, then you acquire something like this, which is not an image, but it's like a sparse version of the Fourier transform of your image. So you have like something like this, and you want to reconstruct an image. So basically, all of these problems, you can put them under the same formalism. You can write them as with this formula here. So here, Y is my observation, is the image that I acquire, and X is the image that I want, that is a known. And they are both linked by a degradation operator that I will suppose to be known and to be linear. And you have some, well, it's not always additive, but for simplicity, we say it's additive noise. And I will suppose that I know I don't know specifically this realization of the noise, but I know the parametric distribution of the noise. So I know, for instance, that it is Gaussian or something else. Okay. Okay. So here you have some examples. An image. It's Homer Simpson, and you have the same image. Here the degradation operator is identity, so I just add noise. Here I have a blur operator, so it's an operator which is looks like this. And here my operator just masks some pixels, so some pixels are hidden. So it's a diagonal operator with 1 or 0 for masked pixel or non-pixel. And I want to recover X from Y. And okay, so the first natural solution will be to do some least squares to try to find X solution of this, a quadratic difference between Y and AX. But of course, you know the solution to this problem. It's explicit, and it's always a bad idea, because here you have to invert a matrix. And this matrix is either not invertible. For instance, if you have masked pixels with 0 on the diagonal, you cannot invert A. And even if it's invertible, it's very likely in most interesting inverse problems that its eigenvalue will be very small. So numerically, you will explode everything and you will have an absurd result. Okay? So you don't want to do this. Your problem is said to be not well posed, and you want to add some kind of assumptions or some kind of regularization on X to make this problem more well posed. Okay, so what people have done since 30 years, maybe 40 in image processing, is that they add regularization. So they choose a function u of X, which makes the problem more well posed. Okay, and we try to minimize this instead of just the least square version. So of course, choosing well u is the most important thing here. So u is some kind of regularizer. It's also called a prior on your data. And in a way, u tells you which kind of images you want to promote, okay? You want to favor. So if you change u, the solution will be different, of course. Okay, so that's just an example. This is what you obtain when u is what we call the total variation. So the total variation of an image X is just the sum of the norm of the gradient of X at each pixel. So it will favor this kind, when you choose this kind of regularization, it will favor images which are piecewise constant, like cartoon images. Okay, so this is an example of denoising. You want to denoise this image and ask me at the end the story of this image, and you obtain a result which looks like this. It depends, of course. You can put a parameter in front of this, and you can regularize more or less. But well, you will have image results with some kind of piecewise constant results, which is good for this kind of image. Okay, so this is, this is more of a historical method, but total variation is still studied a lot because you have always maths to do. And today, the state-of-the-art methods are not TV, but more neural networks, as you all know, I suppose. So, well, in neural networks, you don't really have an explicit function u, but you still have your inverse problem. So, but I suppose that you know that neural networks encode a parametric function. And basically what you do, if you want to solve your inverse problem, the same inverse problem as before, is that you will train your network to find the parameter theta here, which will minimize some kind of quadratic loss on a database of images. So here you have the image, and here the same image after the degradation model. So basically, you train your network as a regressor. It's a basic regression problem. And neural networks are very good for simple inverse problem in imaging. So here, well, through Zoom, it's not so beautiful. Because, okay, you have some compression, but here it's a video denoising. So here you have a video with a lot of noise, and this is video denoising with a neural network from, it's not even recent, it's 4 years ago, but it was, at this time, it was excellent and much better than what you could do with classical approaches. But one of the one of the limitations of this kind of approaches is that when you train your network, most of the time it is problem specific. Okay, you train your network for deblurring, for instance, and then you cannot use the same network to do, I don't know, in painting or denoising. Okay, you can do transfer learning, you can do a lot of things, but you have to retrain or to do something else. You cannot use it as it is for a new inverse problem. So the idea of plug and play approaches is to help you do that. Okay, just use one network to solve a lot of different inverse problems. So I don't know how much time do I have left. 10 minutes? Okay. Okay. So this is basic optimization. You all know gradient descent. Okay. We want to solve this, and this is great. So I call F this part, which is a data term, and U my regularizer. And this is gradient descent on F plus U. If everything is differentiable, I can do this. If everything is convex and okay and smooth, I can do this. What happens if U is not smooth? Maybe some of you know, maybe not all of you. You use something else, which is called proximal descent. So who doesn't know about proximal operators? Okay, so I explain. Okay, so it's very important and it's very easy. Okay, so focus. I want to minimize a function f. Okay, assume it's convex. If f is smooth, I do gradient descent on f. It's explicit gradient descent. But maybe at some point you did numerical analysis and you remember that implicit schemes are always, approximately always, I don't know if it's always, but very often better than explicit schemes. Okay, so I will make it implicit. I will replace xk here by xk plus 1. Okay, so it's almost like gradient descent, but it's not explicit anymore. I cannot compute directly xk plus 1 like this. I have to solve a fixed point equation. It's a fixed point equation. But what I can do is that I can very easily check that this is equivalent to this optimization problem. It's the same if f is differentiable, then I will derive this in t to find the solution, and the solution satisfies this. Okay. But this definition doesn't depend on the gradient of f. So I can use this definition even for f not smooth. And this is what we call the proximal operator of gamma f at xk. Okay, so this is a proximal operator. It's defined for convex function even if they are not smooth. And basically, you will replace gradient descent by a fixed point iteration using this function, prox f. So if you have a routine, if you have a scheme to compute this, then you can do proximal gradient descent. Okay, even if you have a function which is not differentiable. And you can show that the minimum, if x is among the minimum of f, the argmin of f, then it will satisfy the fixed point equation. Okay, so continue to focus. I come back to my problem f plus u. Okay, this, if everything is differentiable, I write this. And if U is not differentiable, then I replace the gradient descent on U by a proximal descent here. Okay, so this is a proximal gradient. Okay, and it's iteration between gradient on F and proximal descent on U. Okay, so in the literature, you have numerous sophistication of gradient descent. This is one of them, but you have a lot of different schemes which are possible. You can put procs on F, you can mix everything, you can do a lot of different things, okay? And all of these methods, in case where everything is convex, they are well studied by mathematicians with clear convergent properties for all of them. Okay. So now, what is plug and play? And I 3 minutes left. No, maybe 5. Okay. I have this inverse problem for this degradation model. Now, look at the proximal operator. Look at this equation and look at this one. Do you see similarities? Oh, yes. So what happens here? A has disappeared. So, but U is the same, and gamma plays the same role as sigma square here. So sigma square was related to the noise in the model, okay? So what we see here is the proximal, we also say proximity operator. So the proximal operator is basically solving a denoising problem, okay? If you remove A here, it's a denoising problem for the regularizer U with a noise of variance gamma, okay? So the idea of plug and play is that you take your proximal scheme and you will replace this prox U, which plays the role of a denoiser, by another denoiser, by any denoiser that you want. So the idea is that in a way, denoiser act like proximal operators. In absolute, it's not really true, but we do as it was. Okay, so plug and play. I take my proximal gradient and I replace my proximal operator by a denoiser. D here is a denoiser. So it's excellent because I can take, for instance, a neural network, which is a denoiser, and I can use it in a scheme like this to solve any inverse problem. So it's like one network to rule them all. Okay, this is first take-home message. It's this one. It has been used with many different optimization schemes and different denoisers. It gives very good results when your denoiser is powerful enough. And it has been used for a lot of different inverse problems. And of course, mathematicians love this kind of stuff because you have a new convergence analysis to do, and you have to find appropriate conditions for conversions. Okay, and I finish with 2 examples. So here it's a deblurring problem. So I hope that we can see. So here you have it's in videos. So you have different kind of blur applied on images of a video, and here you have the so this is those 3 images. They are the results of plug and play restoration. So you remove the blur, but with different networks used for denoising. So basically, they all works well. Okay. And here another example. It's the same video, but you mask 90% of the pixels. So you see almost nothing here. And here you have 2 different networks which are used for G. This one works image by image, so it's not working so well. But this one is a denoiser specially trained for videos, and the results are much better. So it's a work by one of my students. So. Okay. Those are the take-home message, but I already told you all of this. And if you want to play with these methods, we have a GitHub here, storyimaging.github.io, and you have a lot of notebooks, Jupyter notebooks in Python. And one of the section is restoration. Inside, you can find a notebook on the plug and play restoration. And that's all. Thanks.
Are there questions for Julie?
Good evening. Thank you for this presentation. Can we just go back a little bit to the slide with the denoiser? Yes. Yes. So if I understand that clearly, so the denoiser, it's the latent dimension of an autoencoder, and you know what it is. No, not at all. Okay, I didn't get it. So
the denoiser, you can use any denoiser that you want, but it takes an image. It can be an autoencoder if you want, but it can be something else. I don't care about the architecture. It has to work as a denoiser, but it takes an image as input and it outputs an image of the same size. Okay, and that's all. And you use it as a black box. You don't use the latent space or anything like that. I'm not sure to understand what is exactly the question. This is it, yes. So the degradation model is here, okay? And this, it's just a regularizer. Here. But also, absolutely. The rich, because this, okay. When you train a neural network for denoising is the most simple inverse problem in imaging. And basically, if you give your neural network a database with enough variety, it will work on all images. And it's not specific. The training is not specific to some kind of images. It's not trained on faces or something like that. It's trained of very natural images. You just want to remove noise. You don't want to generate images or to recognize people.
Is there another question?
You owe us a story about the image that you had earlier in the deck.
Yes, it's the Simpson image. Because I suppose that some of you have heard about Lena. Huh? And at some point, I was teaching and I decided that it was not possible anymore to use Lena. So I decided that I would create my own Lena. And so it is Simpson, but I don't find it anymore. Where is it? No, it's not here. It's at the beginning, of course. It will be too easy. Well, it's a blurry version here, but you know, he's, what do you say in English? He's il passe l'aspirateur. He's vacuuming, and she's drinking some cocktail. And I started to teach with that, and I teach, maybe 90% of my students are men. but they don't really understand the message. But well, so. But some people are using, it's not just me and my students. Some people that I don't know are using it right now. So it's starting to replace Lena everywhere.
First of all, thank you for your presentation. It was a very interesting subject. And I would like to ask you if you could possibly go back on the beginning to your presentation and expand more on why small eigenvalues would be a problem for us, because I was always thinking that we're not doing inversion because it would be just too difficult to store, especially for images. So it must be a very big matrix. So yes, expand more on that.
Well, for instance, if I take if I take some blur, okay, so A will be invertible. Well, for some blur, it will be invertible, but you will have some very small eigenvalues. And A, you never store A, of course, because it's several millions by several millions. But this, you can write it as convolutions. For blur, for instance, it's a convolution. So it's two, all of this, you can write all of this directly, for instance, in the Fourier space, directly on pixels, and you don't have to store any matrix. Okay, you never store this kind of matrix. So the storage is not a problem. What is a problem here is that you will have a division in the Fourier space, and a division by something which can be very small. And in Y, you have noise. So your noise will completely explode on those pixels. Well, it's not specifically on pixels, but in the Fourier space, you have some frequencies which will completely explode. And your result would be, you will have infinite value everywhere.
If you're okay, she's going to be there during the cocktail section. Go and have a drink, a glass of water with Julie, and she will explain everything. We are going to move on to the next presentation, and you can thank Julie for being here. We tried 4 times to actually get her. So tonight was our lucky night. This should be fine. Yeah. It doesn't seem to move anywhere from here. Okay, this works. Okay. Hello to everyone. My name is Ruth Binkyte, and first of all, thank you so much for inviting me. It's really cool being here, and also in a literal sense. And on a day like this, it's very pleasant. I will talk about fairness in AI and about bias and some approaches to mitigating it.
And it's also not exactly on facial recognition, but maybe there will be some common points, I hope, in my presentation. So first of all, I want to introduce our team. It's a COMET team at Inria and École Polytechnique. This is me. I am a PhD student there. And Katusha WiMLDS is director of COMET team as my supervisor, and also Sam Izua is a senior researcher and my co-supervisor. And I will present some of our work here. And the COMET team is probably mainly known for privacy, but we also work on fairness and on causality. But here I will focus mainly on fairness. So to have a little bit of overview, I will start with some known bias cases, which are quite known. Maybe some of you have heard it, maybe not, but I thought it will be good to have to go a little bit more into detail and have this background. Then I will generalize more about type of bias, and finally I want to have a glimpse about some techniques of bias mitigation and also our recent work in this domain. So let's start with case studies. So the first one is a very well-known research called Gender Shades, and since it deals with facial recognition, it probably can be quite relevant to the topic today. Also there is a Netflix series now, Coded Bias, based on this research. So researcher Joy Bolenwini and Tim Nijebru, they found that major facial recognition algorithms that have quite a good accuracy for white men and even black men and even white women can be very inaccurate towards women that have darker faces. And since it's gender shades, they also had the scale, like the darker the face is, the less the algorithm is able to recognize this person. And why? What is the reason behind it? Joy Bolenwini had a hypothesis that this might be because those darker faced women are very underrepresented in the sample. And it was confirmed because when she collected more data on women that are darker, the algorithms were indeed better at recognizing female faces, no matter of their skin color. Now, another quite scary example is about racial bias in healthcare AI. And this is an algorithm that was deployed in the United States, and it was meant to predict the risk or health status of the patients, and based on this, accept them to some healthcare program that provided a faster access to healthcare and facilitated this process. The researchers found that at the same level of health status, Black people were given much lower scores by the machine, and as a result, less eligible Black patients were accepted to this program. And why? Once again, what the engineers had to train the algorithm was healthcare spending, which is a very readily available variable that can predict health status quite well in general. So it was all good intentions, but it happened to be that it was also correlated with race in such a way that Black people in the United States are usually less wealthy, less able to afford healthcare, and so less spend even if they are not really healthy. And on top of this, there are the problems of trust because of white-dominated healthcare system, and so in general they were using it much less. And how could those researchers see this comparison between health status the real health status and healthcare spending? Well, they collected longitudinal data and follow-ups on on much more harder to obtain biomarkers that would be more informative of the real health status. But this is not so readily available and not so easy to use every day. And now I a little bit covered what were the sources of bias in those cases, but now I want to make some general observations about it. So first of all, coming back to machine learning process, we usually think that bias can enter in any stage of this process, but it's most prominent in the data. And here I will focus on the bias that stems from the data that is used for training. And going back to those examples, two main types of bias would be representation bias. So some group is underrepresented in the data. We have very few samples of this group, and the algorithm cannot learn to recognize them well. And another source of bias is something that can be, it can be divided into also many subcategories, but very roughly it could be historical bias. And because of historical reasons, discrimination and difficulties that some groups of peoples had to go through, they have lower occurrence of positive labels in terms of decision, but it could be also the features on which decisions are based, like education level could be lower or let's say STEM education can be less frequent for women than for men, let's say. And we do not think that this is because we are not capable. This is a correlation because of some historical reasons. And let's look a little bit more closely at this underrepresentation bias. So the very fresh study that we done with my supervisor, we looked at how underrepresentation bias affects other data sets not used for computer vision, like benchmark data sets for fairness, very often used in the field, adult compounds and Dutch census. And we made some experiments that we were changing the proportion of females or racial proportions and see if different fairness metrics were changing as compared to the original population. And what we see is that it's actually, it has to be very extremely low number of this minority group for this underrepresentation bias to have effect. So we see it here, but it's we change a little bit the scale so it could be more visible. But here it's something that is smaller than 3%, and we think it's not contradictory to the study gender shades, because they were also looking about intersectional sensitive attributes. So of course the group that is both women and Black is smaller than any of gender or racial groups. So it could be it. And when it comes to mitigation and trying to overcome this bias, once again, it worked quite well in this setting, in facial recognition, and more samples with women help to solve the problem. But from our experience, we see that when representation bias is combined with historical bias, meaning that it's not that we have small number of women in the sample, but we are also they have we are more likely to have negative labels than positive. Augmenting the data in a simple way doesn't really solve the problem, and it can even increase it. So here we keep the male group constant and try to increase female group. And at first, we do it by just random sampling. We randomly sample more females from the same population, and we add them in the data. And what we see that even true positive rate, which is based on accuracy and should be increasing at least this, it's actually decreasing, while male kept constant, and the bias, which is the difference between the two, is increasing slightly. And the same is with probability of positive label. It's actually increases as we increase the number of women. And well, we thought, okay, so it seems that at least in this case, adding simply more samples doesn't really work. But what if we add more samples with positive labels? So we do some equalization in terms of the probability of positive label as well. And here, yes, we can see that the probability of positive labels increases for women, and the true positive rate also increases, and the discrimination goes down. And we have this positive effect here. And just to reflect a little bit what could be different from gender shades example, I don't have a very definite answer, but from my intuition and from some hints I saw in literature, it seems that here our goal is to decouple the label and the sensitive attribute. We want it to be completely independent. While in machine learning, in computer vision tasks, where we want to recognize a person, in a sense, being female is also the part of a label. We want to recognize person who is female, who is Black. So it's actually something that we don't want to decouple. And here it's different thing. But okay, so we can have this mitigation by increasing samples with positive labels, but here discrimination is still now going to the other direction. So negative number says that now males will be discriminated. So where is actually the point where we should stop? And many bias mitigation algorithms, either it's working on data or in processing directly on the algorithm, they mainly aim to satisfy statistical parity. There are numerous fairness notions. It's part of a problem in the field is which one to use, not so much how we achieve it, but which one should we use. So statistical parity requires the probability of the prediction, positive prediction y equals 1 should be equal for one group of sensitive attribute and another group of sensitive attribute. But now when we talk about historical bias, does equal always mean fair? Because I will go back to another example of healthcare algorithm. And what the researchers found there, that Black patients on average have 26.3% more chronic diseases than the white ones. So this means that we should have more Black people accepted to the program, not the equal amount of Black and white people. And okay, we have a little bit more nuanced fairness notions, which is something that is called conditional statistical parity, where we want equality for both groups in terms of positive label prediction, but conditional on E. And E here would be an explanatory variable. And the idea comes from disparate impact legal framework, which is known in US, used in US. And it says that we might tolerate some extent of disparity, given that it is justified by some business necessity. So if it's a hiring scenario, and E could be an education, we have different hiring rates for different groups, but we might justify it if this group has higher education in this field, which is necessary for this job. And quite similar in spirit is equal opportunity, where we look at the real label, let's say it's a ground truth, and we also want this equality of predictions, given that the true label is also positive. But here we have to assume that we have our explanatory variable and we have our true label, and that they are not biased. And just to remind, in the healthcare example, they also had this healthcare spending, and it seems a reasonable explanatory variable E or a label Y if you look at it, but it's biased itself. So now, motivated on those examples, I would like to make a little non-technical glimpse into our latest work. It's not even on archive yet, but if you want details, just let me know afterwards. We want to we created a framework to integrate external causal knowledge to pre-process this biased attribute and finally the label, based on what we truly believe is the root cause of this disparity. So if we look here, it could be the sensitive attribute, and E explanatory attribute could be the healthcare spending. Z would be the bias proxy, which is, sorry, this would be the real health status. Z could be the bias proxy, which is healthcare status. Healthcare spending, sorry, and the decision is based on this bias. If for some of you who are familiar with causality and causal structures, this would be a collider structure. This means that those two either are not causally connected, or they can be, but this structure creates additional relationship which is non-causal, and we don't want it to be in the data. We want to get rid of it. And here we make an assumption that we have this external causal knowledge. So as those researchers, they measured those true health status signaling biomarkers, and from here they could infer the bias mechanism, meaning what values of healthcare spending are for this true health status and for this exact race. It's hard to collect. It can be pricey for every training data, but if we done it once, maybe we can use it and use it in other contexts. But for this, we need to use expectation maximization algorithm, so we can find the prior probability of E given S, or healthcare status given race, because it might be different than in the population where we made experiments and collected additional data, let's say in Europe, different than in United States. But given this data set that we want to pre-process with the value of the sensitive attribute, with the value of bias proxy, and this external bias mechanism knowledge, we can infer this prior probability of E given S, and then we can estimate true E given values of Z and S on individual level, and base our decision right on this, what we believe is a fair reason for the decision. And we made some experiments where we synthesized data in this spirit. So here we have, and we compared it to a well-known algorithm, disparate impact removal, which aims to satisfy disparate impact, or this is similar to statistical disparity, but it's a ratio instead of subtraction. And what we did, we generated data with the orange is the true distribution for group 1, and the magenta is the biased, and the green is the true distribution for group 0, and this greenish blue is the biased one. And we see that the true means are not the same. We assume that here that it might be higher for one group. And our algorithm approximates the true distribution with quite a good precision. And by the way, it also works if we assume that the means are different, equal, or if it goes different directions, so it adapts. Whereas if we aim for this equality, the distributions are equalized by lowering the probability of high values just a little bit for S1 and increasing just a little bit for S0, and we have them equalized. But if we have this causal knowledge for which we aim in situations like this, it doesn't really improve fairness, what we would like to do. And I don't know, I'm quite finished, so thank you. Yes, and since I tried to make it quite high level because I didn't know the prior knowledge in the audience, but if you have more questions, and please reach out, and thank you very much once again.
I'm sure you have questions.
Hello, thank you for the presentation. I just wanted to know, how do you do if you want to handle a lot of different variables that you want to for which you want to remove the bias?
With this method?
Yeah.
Well, then we should do it one by one, because each of them could have a different mechanism. Unless we can make some compound variable and assume that it has the same mechanism, maybe we could do this, but this is a little bit of, it requires a little bit of precision. We have to know this mechanism, and we can't assume that it is the same for many variables.
Thank you very much for your presentation. I have a question about the moment you talked about achieving parity, right?
Yes.
When the gender, for example, wouldn't matter. So my question is, isn't it just better not to use gender from the beginning in your model if in the end you will try to do data augmentation, achieving the fact that gender will not be correlated with the label?
Yes, so this is where fairness as a discipline started. The first idea was, can we just remove sensitive attribute and we're fine? But many studies after showed that it creates much more problems because there are many other variables that are correlated with gender or race. Let's say, for example, zip code. It can be so informative of race in United States, let's say, and we just remove race. We don't really know what else to remove. Especially with the more complex is algorithm like neural networks, the more we are able to find those little slight connections that we wouldn't even be able to detangle. So there is quite a problem in European law because very often we cannot collect sensitive attribute and we cannot use it. But without using, we cannot really measure. So there are some studies how you can get around this, but I'm not very well aware of them. I just know that it's being done. But the idea that we stick to is that you should have sensitive attribute in your data, at least for measurement. At least that you could use it to evaluate if you had some bias.
Thank you for the answer.
Good evening again. Thank you for your presentation. I have a question concerning the first paper. So you used, if I'm not mistaken, the Dutch data census, right? And you performed the data augmentation on this dataset, right? So it was like tabular data. And
Yes.
How did you
Yes.
how did you perform the data augmentation on tabular data, with which algorithm?
So we did a very primitive thing. We didn't use like disparate impact remover, which equalizes the things in a more sophisticated way. We wanted to mimic what would be if you go out in the real world and collect more data. So basically what we did at first, we took a smaller portion of this data and then randomly sample more women than men and augment in this way. And in the next experiment, we randomly sampled women, but those that have positive labels.
Okay. Thank you.
Any last question? So thank you very much.
Thank you.
It's Francesca.
Yes, sure, absolutely.
Francesca. All right. So my topic has got nothing to do with the theme of the night. It's much less interesting than what we just heard. And it's also very corporate. But it's the perfect transition to the cocktail session because you all gonna wanna have a drink after this. So thank you for having us tonight. Thank you to the organizers and the hosts for creating this space. My name is Francesca Iannuzzi. I'm head of data science at Maisons du Monde. And what I would like to talk to you about tonight is a project my team and I have been working on for almost 2 years now. What we enjoyed, what we struggled with, and most importantly, what we've learned. And I think that most of you will relate to this because really it's just the behind the scene of any major data science driven process transformation in a company, especially a company that is not digital native and that has been running a pretty successful business for decades without a data team. So about Maisons du Monde. It was founded in 1996 in Brest, Brittany. The headquarters today are in Nantes and Paris. Paris is just around the corner in Rue Amsterdam 55. We are over 8,000 employees, mainly in the retail division and about 1,000 in the corporate division. We are present in 9 different European countries with 357 shops. We have an e-commerce platform, and France, Spain, and Italy also have a marketplace for external vendors. Important for what I'm going to talk about later, it's a publicly traded company. You'll see what I mean by that. So as you may know, we sell several thousands of different products each season, belonging to 3 main families: home decor, furniture, and what we call multiple products: tableware, candles, etc. And these products come from a range of different suppliers. Maisons du Monde has its own factories in Vietnam, but then also buys products from other suppliers and vendors in Asia, and more in Europe for reasons that you can easily imagine, like corporate social responsibility, but also shorter lead times or shorter shipping times, which is also something I'm gonna get back to later. Now about the data team, they're not all that happy. This is just marketing, okay? So I should say data and agile since April. We are part of the larger IT unit. We're not within a specific business unit. That sometimes is the case. We've been there for a little over 6 years. Current CDO is Elodie Prudhomme, and otherwise we're about 40 collaborators covering the usual data flavors from data operations to engineering, science, analytics, and visualizations. And our technical stack revolves around GCP. Now, The data science team is a bit younger, about 2 years old, 5.5 collaborators. And we also work, of course, on GCP and specifically Vertex AI, but I will get back to that later. I would really like to introduce this 5.5 one by one, because they're mainly here and they're really smart, and you should definitely go talk to them later, especially if you have technical questions. So, from the oldest member of the team, Nikolai, he's not here tonight, data scientist and ML engineer. Melissa, she's there, data scientist. Rowa is over there. She's no longer with us because she finished her M1 internship in March, but she worked on this project, and we'll talk about that later. Svetlana, so there, data scientist and analyst. Jan, she's doing her M2 internship with us right now, and the famous 1/2 is Loic, who is a data engineer that we borrow for about 0.5% of the time, 50% of the time, and to work on our project. So he's not here, but his boss is here, which is Caroline. And she's there, and you should also go talk to her because she's a data engineer. And there are not that many women in data engineering, unfortunately, so kudos to her. Now to the topic of forecasting at Maisons du Monde. So I would start with like the most basic definition of forecasting to set the stage. So a forecast is a best estimate of a future outcome, an expectation of what you think will happen, which, mind you, is not what you would like to happen. This is the target. And so a company like Maisons du Monde would set a financial plan for the year based on expected income and expenses. So based on a forecast, because otherwise you would be completely delusional, but not the forecast I want to talk about tonight. So that is the budget or the target. And then the forecast that we're interested in tonight is what you do regularly to see if you are going towards your target. Okay. And this, you can imagine, is particularly important for a publicly traded company that is bound to communicate to regularly to shareholders and the market more generally. And this was the slide where I was going to spend like 15 minutes telling you about all like how this budget gets split and into operational objectives for each different business units, and then each business units run the forecast to see if they're going to hit their objectives or not. But I absolutely have no time to talk about that, so we'll only just give you one example, which is the one that is most relevant for us, that is revenue forecasting. So you have your yearly budget, the 12 months, you split the budget into each month, correcting for seasonality. And then every Monday, you sit down with your dear colleagues and peers, and you reforecast the end of the month. Because you want to know if you're going to reach the target or not. And if you're not, then you're going to have to run some magic, do some promotions or marketing. Or if you think you really are not going to make it, you have to communicate it up. So this is a very classical use case. How is this done practically? It's a lot of Excel files where you get historical data, and then you extrapolate the data a month into the future and then correct it using judgment. So knowledge of the sector. It's a very top-down approach. You forecast the top level and then you break it down to smaller bits if needed. And it has its advantages. I mean, it works well. Business has a very strong sense of ownership of the process, of the data, which comes from us. And this thing about the judgment, it really is quite crucial because you can inject some very refined information about the business context into the forecast. So very well. Now you can imagine there are also inconveniences to that approach. It's time consuming. It's non-scalable. And sometimes there are external factors that you would be better off modeling in a quantitative way instead of like injecting it through a human judgment. So great, data can help, the data team can help, but what does that imply? It's not just a change in the algorithm, right? It's a change in process, it's a change in ownership, it's a change in roles that people may have had for years. So if what you're doing is good enough, why bother? Why would you go through all that? Well, sometimes unexpected things happen. And what was good enough until the day before may not be good enough anymore. And can you imagine what that may have been for a company like Maisons du Monde? Yes, okay, well, I had a thing prepared in case you, but never mind, thank you. Can you guess what that is? I give you a hint. I said 357 before. What was that? Shops. So this is the number of operating Maisons du Monde shops between 2018 and 2021. And there are 3 major dips, which I'm sure you realized are related to the 3 French lockdowns, because most of our shops are in France anyway. So yeah, of course, COVID has impacted business, to say the least. Though Maisons du Monde came out of it pretty well, and even at some point profited from it when, you know, people were stuck at home and the only thing they could do was decorating their gardens, you know. But it's not just the shops, it's factories in Asia weren't operating anymore, and the maritime transport wasn't running as usual. And so the old supply chain was disrupted. And at some point, we weren't getting the products that we were supposed to sell, not in the right quantities, not at the right time. So yeah, I'm sure you can imagine how that made for some very long nights for some people. Fast forward to September 2021, 3 months after the end of the last French lockdown. It was 2 of us in the data team. None of us had ever worked on forecasting beyond exercise class, and we get a phone call. Look, supply chain is disrupted, shippings are delayed, our stock coverage will hit an all-time low. This is uncharted territory, and we cannot quantify the impact of the revenue on the revenue of the last quarter of the year. Please come up with something. You have 5 days. Cool. So what do? Brutal transition into technical aside number 1. You use Profit because you have no time. You are no forecasting expert, and you need to use external variables. You need to perform causal forecasting, and you need interpretable results at the end. So that's the way to go. Profit is an open source library developed by the core data science team at Facebook and released in 2017. Now I would like to go on a tangent for about 20 minutes talking about open source, but I can't. And also, I would like to tell you about how Profit works, but very conveniently, I don't have the time, and Melissa is over there, and you're gonna ask her all the questions you have later on. The only thing I'm gonna say is that this was, of course, a very notebook intensive effort. And it lasted about 3 months because we had a number of different demands, and we were reforecasting every week. At some point, we were pair programming with executives on this. It was a bit crazy, and I still can't wrap my head around it, but we managed, Nicola managed, but I was there as well. We managed to also, on parallel, to set up a process, a workflow for data processing, modeling, and visualizations that by the end of the 3 months got us to some sort of semi-automated workflow, which was really quite impressive. What about the results? So I'm gonna just show you 2 series. I had to mask the axes, unfortunately, sorry about that. 2 different product categories, 2 different behaviors. So on top, you have a product category which clearly has a very strong seasonality. You can see the impact of COVID over here, which we managed to model pretty well. And on the bottom, you can see a much noisier series. And so this reflects into a larger confidence interval, if you want. And the dots are what turn out to be the weekly gross revenue for the period that we were forecasting, so the last quarter of 2021. So we did do pretty well. We overestimated the gross revenue by a few percent, but most of the points fell into our uncertainty interval. So we were pretty happy with that. So 3 months of very intense work. We learned a lot about forecasting. We set up what was going to be the prequel to our automated workflow for our data science use case. And most importantly, we showed, the potential of a data science driven approach. And we got sponsoring to start a proper project, which we figured would be something like this. You leave the country roads of proof of concepts to join the project highway, where you have a team of motivated data and business professionals that will go hands in hands towards a common goal. And you will sit with these people and define the objectives, the deliverables, you break it down into chunks, and you will project and map all these chunks onto a calendar. And you will define dates and agree on dates for the deliverables, and put all that and write all that beautifully into a document that will be approved, so that the project can get, we can kick off the project and work can start in a very organized, rational manner. Work that, of course, you will share with your dear shareholders in weekly or bi-monthly rituals, where you will discuss, advancement, solve doubts, and make decisions for the future, right? Well, silly you. No, this is what it was. So we had to steer, of course, the objectives constantly, because we had to adapt to evolving demands. So at some point, you may have an urgent demand that is completely tangential, but it's very urgent. So you have to set time aside to deal with it. And then you may have a new business stakeholders that comes along, and you have to sit down with them and find a new consensus. And then after that, you have to push back on some, contradicting demands. And then sometimes you have, on the contrary, you have to accept that the business context is evolving so rapidly that what was a priority 3 months ago is not a priority anymore. And then the cycle starts again. So this brings us to the key learning number 1. Life is not a Kaggle competition. You're not on your own or with like-minded peers. Improved performance is not the only thing that matters. It's not the only road that you have to walk, because in the end, you're not going to deliver a pickle file. You're going to deliver, ideally, a data product. Definition below, have the time. So how do you get there? What do you need in order to get there? Well, you need, of course, sponsorship, you need time, you need resources, you need consensus. And you need to make sure that you have all 4, because otherwise you're doomed. And you also have to develop that intuition that tells you when these things are not really there or are not there anymore. But then you also have to, being flexible, learn, develop the business mindset and develop an understanding of what business priorities are. So basically, you need a master in the sociology of data science, which I don't know if it exists, but it should definitely. Yeah. Fast forward a year and a half to today. Where are we? This is our beautiful hierarchy of web sales. You got total web sales at the top. You've got web sales by country in the middle, and then you got web sales by country times the 3 product families that I told you about before. We do not model total web sales explicitly. We aggregate to them. We model the country level and the country times product families level. So overall, it's 44 series, which are modeled and reconciled, meaning the country level and the country times product level will communicate and adjust each other accordingly to be coherent. Our target variable is daily gross revenue over an horizon of about 2 months, which we're also working on trying to convert to consumer sale units in order to address other needs more on the supply chain side. Now, this would deserve a talk in and of itself. I told you about our automated workflow that we started developing end of 2021. Now this has become a proper automated workflow based on Vertex AI. So we generate new predictions every Monday. We store them in our data lake, and we expose them through a dashboard, a ClickSense dashboard. And the modeling part, this is just one example, leverages Vertex AI, which is GCP's platform for ML workflows. And we devoted a big chunk of 2022 to lay the groundwork for this to happen. And so now we have a much more solid base to keep on building on this project. About the models, we kept Prophet and we added 2 more, NBITS and LightGBM. Why? Because these 2 were ranked pretty high in the results of a major retail-oriented forecasting competition, which is called M5. You have the references below. And I should also say that we are indebted to Darts, a Python library for that makes it somehow a bit easier to access time series algorithm and functionalities in general. Now, we have these 3 models, but there is a 4th model that is actually very important and that gets often overlooked. Can you imagine what that can be? Sorry? Oh, damn it, tonight I cannot trick you. So yes, because yeah, so you have your forecast from your main models, and then you want to assess how good they are. And what do you do to assess how good they are? Do you go and compare them to reality? No, you compare them to a naive model. So a very simple model that is basically just, in our case, it's like an average between the value of the series, the last value of the series, the same value of the previous week and the previous year corrected by trend. Which takes us to key learning number 2. A forecast is evaluated against the baseline, not in the void. Because as we've seen before, you may have series which have a very strong signal that are relatively easy to model, and then you may have series which are dominated by noise and that are basically unforecastable, and you cannot compare metrics of the 2. So you should have a baseline. You should basically, a baseline is just what is the alternative to your forecasting? Is it no forecasting? Is it a naive forecasting? Is it a business forecast? And are you advancing that baseline or not? So I think it's important that you have this in mind. I think we overlooked a bit throughout our project the importance of comparing systematically to a baseline. Now, how do we do? Well, let's take 2023 year to date. Average error on a daily revenue over a 2-month horizon. LightGBM, 14%, which is pretty good. Naive, 28%. Whew, we're good. We're doing good on that. Now, how do we do with respect to business? This is more complicated because you have to construct the business baseline, which is time consuming. ROA did it for the first quarter of the year, but we do not have an automated process for like continuous assessment. But based on what we have and on what ROA did, we advanced the business baseline by a few percent on the 1 week and 1 month horizon, and aggressively improve it on the 2nd month. But these are averages, and averages sometimes may hide very important insights. And indeed, we are overall, advancing the baseline by a few percent because there are periods of the years where we are much better than business baseline and periods of the years where we are not, which takes me to the areas of improvement. So our models lack comprehensive knowledge of promotional activities, for example. So in operation heavy periods, our forecast may lag compared to what's provided by business. And there are things that we can do, there are things that we can improve upon, and we're working on that these days. But there is a limit to how good we can get, because we will never have all the knowledge about everything that happens. And sometimes this knowledge is not even available in a format that we can use. And there is necessarily no track of all the times in history that this action has been taken. So it's difficult to model and to inject in our quantitative modeling. Which takes me to key learning number 3, which is the last one. Judgmental forecasting is there to stay. Business stakeholders will have the last word. They will have to be able to inject their knowledge in your data-driven forecast that you will provide, and you should factor that in when you sit with them, redesigning the process and designing the deliverable or the data product that you're gonna provide them with, because in the end, you can have the best forecast in the world, but if it results in the 15th Excel files that they have to plug into their old process, it's not gonna make much of a difference. Conclusions, or what ChatGPT thinks my conclusions should be. So let's read what she says. An enlightening voyage. It's been a challenging yet rewarding and formative journey. It absolutely was. From start to now, despite navigating a path that wasn't always straight, we find ourselves in a far stronger position today. Also true because we are getting better and better with partnering with stakeholders. We advance hands in hand. Okay, she's taking it a bit too far. Ensuring our progress aligns with their needs and goals. And we laid the foundation. We have established a robust technical infrastructure that is capable of supporting any future evolution of the project, ensuring we are well prepared for what lies ahead. I couldn't have said it better. Thank you, ChatGPT, and thank you everyone for listening to me.
Questions for Francesca? So if you don't mind, I'm going to try to wait for someone else and then I will come at you.
Thank you so much, Francesca. It was a really enlightening session. So my question is, how do you balance when you go for meetings and try to strike within the stakeholders? I know you mentioned that it's a challenge, but can you go into deeper and give how you're able to handle such situations, like when you go into meetings and you're telling them that this is what the data is saying, and then the stakeholders are saying that no, we're saying it from this point of view. And also, how do you manage talking with your other colleagues to try to improve their processes using data, because most of the time they won't be ready to go with you, because like you said, a lot of rules were changed, a lot of processes were changed and all. So how do you manage situations like that?
Yeah, right. I'm not sure I solved that problem, but yeah, I mean, there are contexts that are really objectively difficult. Sometimes, you have even multiple stakeholders that you have to deal with. They get pressure coming from all different directions, and sometimes, even with best intentions, it's really difficult to advance together. I think there has been, if I had to do this again, I think I would make more of an effort in communicating proactively. So for example, I think there were some things that got lost in translation, in a meeting we had a couple of weeks ago, basically, we got someone asking us, but I mean, do you realize that the business stakeholders will always have to, correct the forecast? And I'm like, yeah, I mean, and apparently that wasn't clear, because we changed so many stakeholders, we changed so many, the people that we had to deal with, they changed a lot. So things that for us were obvious, they weren't necessarily obvious for the new people coming in. So I think I would stress more on communication. I would just try, and I mean, if we didn't do it, it was impossible. But I mean, I think we really sometimes would have needed to meet up much more often than it was possible. We wanted to meet every week, every 2 weeks, but it was impossible to set up. So sometimes we would diverge for reasons that were just lack of communication, really. So I think that's something that it will also be quite attentive to. And then, of course, the product, like the deliverable that I was telling you about, that's I think the key, because if you know, the business stakeholder, they feel that they can own the deliverable, that they can, you know, interact with it instead of just, you know, getting some sort of external truth pushed to them that they can only just use without interacting with it. I think that probably would have facilitated their adoption much earlier. And yeah, then the sponsorship is also critical. And, you know, sometimes you have this disconnect whereby you have the direction and executive level where they want to promote change or like a change in processes and data-driven whatever processes. But if that doesn't trickle down to the bottom of the hierarchy, it's not going to work, because in the end, you're not going to be meeting with executives every day or every week to discuss the advancement, except in Q4 2021. But you have to get the consensus down to the operational layer. The people that you actually work with will work with every day, and the people that are going to use your product. So that's more of an organizational challenge that goes beyond my position, but I think this is really crucial. And I don't know if someone else has ideas, feel free to share, because I don't. That's all I can say for now.
We're going to take 2 questions because I think you noticed we're a little bit late, but then we can all have a chat together.
Thank you so much, Francesca, for your presentation. The change management organization challenges aspect, that's what I do too. But my question actually is in the context of COVID. If with your predictive modeling, if you guys do stress tests, now, because now that you've had to do forecasting and deal with lead times, and with given the context of what happened with COVID, do you guys do stress tests to take into account different variables now that might exist or might end up existing in the future?
Yeah, good question. So we started our forecasting project after COVID, and at the beginning, because we were forecasting in the POC phase overall revenue, we also had to forecast the part coming from stores, physical stores, and not just the web part as we're doing right now. And so there, it was crucial to model COVID, and it was one of the reasons why we used Profet at the beginning, because it was easy to add a regressor. And we used actually the graph that I showed you with the shops and the dips is one of the regressors we used, and it turned out it worked pretty well. What was more difficult, and we still haven't tackled really because we have other priorities, was to model how the fact that the shops were closed translated into extra web sales, because that is a much subtler signal in the series, which we tried. We were better off without it, so we didn't do it. We were hoping that just the trend would pick it up, but it's definitely something that I've been thinking about, and we should go back and try, because things like that may happen again. Web sales are much noisier than shop sales, and so it's a challenge. And the fact that we haven't factored in this kind of leakage from the shop revenue to the web revenue is something that keeps me up at night every now and then. And other factors. Okay, so our team is working on promotional operations, and we have modeled sales and private sales. How do you call that? Whatever, private sales and sales. But there are a lot of other promotions that exist and that we still haven't managed to model, sometimes because it's objectively difficult to model them, and sometimes because we don't have the data. We have to reconstruct the history and also just find a way to, you know, have the future operation come in to be fed to the model, which is really quite, yeah, it's not easy to do. It takes time.
Hello, good evening. Thank you. Very interesting. I have many questions. I have 4 questions. Promise it won't be long. First question: what is the algorithm behind the Prophet? Second question: with LightGBM, how did you frame your data set? Like it's a time series, day one, the number of cells, many variables with the derivative of the past cells, and then the prediction for the next day. This is just a question, how was the problem framed? Third question, you say that you use many algorithms. So, I mean, like you make 3 predictions with 3 different algorithms, then you make the mean so that you have not, okay.
No, yeah, I get your question, but the answer is no.
And last question, what about the leakage? Like future that data in the past data that you use for, did you, I don't know, check that or implement a mechanism to check that there wasn't like future data in the, for each timestamp, for example?
Okay, so to the first 2 questions, I'll give a very, very high level answer, and then you ask Melissa later on. So Prophet is an additive model that basically works in terms of trend, seasonality, and holidays. Yeah, I can just, yeah. So it can account for multiple seasonalities, trend and holidays. Holidays, I think, for external factors, so to say. And it's basically a curve fitting mechanism that it's really not, so it's still, I would say, a pretty classical approach at forecasting, because you still, you know, you are a bit dogmatic in the sense that you start from the point of view of a time series being decomposable into trend, seasonality, and holiday. But it really, it is quite well explained in the paper how they differentiate themselves, for example, from ARIMA or other things. I think it's much more flexible, it's much faster. It can deal with like missing data and multiple seasonalities, which is something that in ARIMA is not that easy to do. So, and all the rest, you ask these people. And LightGBM, I think the table, like the data frame, basically that you use is past, like lagged data. The size of the input windows, or the lagged values, is decided during the hyperparameter search. And then you have it's basically a regression, which is based on a number of historical data, lagged data, and external promotions, external factors like, all the covariates or regressors that you may have. And we don't do ensembling. Rowa, I think, looked into that. We haven't done an exhaustive test about, like, we have a year and a half of prediction that we stored and we started analyzing, but we could do a more extensive test on whether or not we would do ensembling could bring something to our results. For now, we have mixed results on that. And the last question, I'm not sure I got it. If you can just repeat it. Yeah. Okay. Oh, I don't think we have that problem. Like, I don't think we explicitly, like, but wait, considering the way our workflow is built and how our data is prepared, I don't think that that's a possibility. But then if you think otherwise, let me know. We should check. But no, I think, well, we do cross-validation on it. Is that what you? Yes. But we separate, like, so we have a cross-validation data set, which of course, well, you have a time dimension that you have to respect. And then we have a test data set that we keep free from training, where we assess the results before, you know, putting them in production, where we train until the last available day. So I think we can talk about it more later if you want, but actually I don't think we have many problems with that one. I don't think we do.
Thank you very much, Francesca.
Welcome.
So I think you got it. We're not going to do the discussion part because we had very fascinating talks tonight, and I think we're starving, we're thirsty as well. But I wanted to thank the three speakers because I think you noticed it. We always like to highlight people from academia, so now you can go to bed. So people from academia and also from the industry. And usually we like also to build bridges between areas of research. So we talked a little bit about images with Julie, ethics with Ruthie, and then we had lots of fun with you, Francesca. And I wanted to thank you because I think it's one of the first times when we have someone coming with the whole team. And it's actually, you know, it's actually brilliant. Why? Because when you listen to someone making a presentation, there's minutes, hours of preparation. And all the women or non-binary people who talked at our meetup, they show the way. And by inviting your team, you're also showing a great example. So by saying that, I would like everyone to remember it. And there's also a reason behind that. We're always looking for new speakers, experienced ones. So if you have an idea about a speaker you would like to listen to during one of our meetups, share the name with us, or you can also share a name of someone who never spoke before and that we could try to approach. So now have fun, network, and thank you very much.